Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 10, Section 1, Areas of Parallelograms and Triangles. So we have a formula for a rectangle and a parallelogram. So a rectangle is a parallelogram, so we can use the same formula. The formula does work for both of them. So the area of any rectangle is the product of its base and its height. So most of us are very familiar with that one. Now, a parallelogram, we can also use the same formula. The area of any parallelogram is the base times the height. Now, a lot of times what we like to do is we can think about this formula in terms of a rectangle. So if we take this parallelogram and suppose we cut it right here, we could pick up this piece and we could move it to the other side. Now, because it's a parallelogram, if we put it in here, it would form a right angle and it would perfectly match up, and what we'd end up getting is this part would be cut out and we'd end up getting a rectangle that had the same base and height. So that's one way that we can think of a parallelogram in terms of like cutting off and moving, and we end up getting a rectangle shape. So we've changed the shape, but the area is not going to change. Some people like to do that. Some people like to, think about it as being, they can cut it here, and you end up getting like one rectangle here, and then you end up getting two triangles there. And if you put those together, you end up also getting the area of all combined is the base times the height. So area of any parallelogram is just the base times the height. Okay. The base of a parallelogram is any of the sides of a parallelogram. So when we talk about trapezoids, the bases are the parallel sides. Well, if we have a parallelogram, any side can be called the base. And the altitude is a segment that is perpendicular to the line containing the base, drawn to the opposite side. So when I say altitude, I'm actually talking about the physical segment that's perpendicular to the line containing the base. When I say the word height, I'm talking about the length of that altitude. So a lot of times we like to interchange altitude and height, but they do have slightly different meanings. The height is the length of the altitude. Area of a triangle is 1/2 the base times the height. Okay, so the area of a triangle is half the product of a base and the corresponding height. One of the ways that you can think about this one is turning it into a rectangle. So if we draw the altitude here, what we end up getting is two triangles, and we could reproduce each side and then we could match it up. So we could take this part and duplicate it and put it up there, and we could take this part and duplicate it and put it here. And if we took the whole rectangle, it would be base times height, but we only have half of the triangles, so it's 1/2 the base times height. You'll find with a lot of formulas, I like to break them down, and in this way, so I can remember them. We will get so many formulas in the next chapter that it's really nice if you can come up with a nice consolidated way to think about it. That way, if you ever forget the formula, not that you're going to forget the formula for a triangle, but if you ever forget the formula, you can kind of recreate it in your mind, and it really helps you to remember the formula. So the base of a triangle is any of its side, and the height is the length of the altitude containing that base. So now we have a cool problem. When designing a building, you must be sure that the building can withstand hurricane force winds, which have a velocity of 73 miles per hour or more. The formula force equals 0.004 area times the velocity squared gives the force F in pounds exerted by a wind blowing against a flat surface. A is the area of the surface in square feet, and V is the velocity of the wind in miles per hour. Okay. So what we need to find is we need to find the area, and that just involves finding the area of the shed. Well, the area of the shed has two parts. It's got a triangle, so 1/2 base times height, and this is 20. So now a lot of times when I write these formulas, I like to write out exactly what I'm going to do. And so I'll write the area total equals the area of the triangle plus the area of the rectangle. And what that allows me to do is be able to go back and say, oh, yep, I made sure I got both parts. And then when I have all the little formula parts, you know, I'm not trying to figure out if I'm missing a part. Okay? And most of the earlier problems are easy enough that we don't have to do this, but especially when we start getting into like frustums and some pretty complex figure, it'll be nice to start with just a basic formula. So we've got the triangle. That's going to be 1/2 the base times the height. And the rectangle is just going to be the base times the height. So this is going to be 10 times 6, which is 60. And this will be 20 times 12, which is 240. And so this is going to be 300. And if we take a look, it's in feet. So this is going to be feet squared. Okay. Now, we also need the velocity. And they give us that at 73 miles per hour. One thing to look at is the area is in square feet and the velocity is in miles per hour. So when we plug these into the formula, we don't have to do any unit conversions. So it specifically tells me that area is in square feet and my area is in square feet and the velocity is in miles per hour. And sure enough, it gives me the velocity in miles per hour. So the force is going to be 0.004, the area is 300, and the velocity is 73 miles per hour squared. So if I put that in my calculator, I get 6,394.8, and my units for this are exerted in pounds, so this would be pounds. And that's it for today's notes. Thank you for watching. Have a great day.